Here's the schematics to my v9958 video card. It's functionally identical to the old version. It's just the difference is that it delivers a better quality video signal. Um, it's got the Yamaha v9958 graphics processor. It has 128 kilobytes of video RAM. It's capable of outputting a maximum resolution of 512 by 256. So it's not a lot to work with, but it is what it is. It uses a 4-layer circuit board and not a 2-layer circuit board. With the 4 layers, I was able to make one of the middle layers a 5-volt voltage plane, and then the other middle layer a ground plane. The normal signals, even ground and power traces, are still present on the outer layers. Auto routing is hard. I was still figuring out how to fight with the auto router while I was making this, but doing the routing and traces the way I did was good enough. It still uses this Sony, what is it? Sony CXA 1645p RGB encoder. I actually use this for converting various signals from the v9958 into composite video and S video. It's not too complicated. One big disadvantage of this chip is that it does not output a V-Sync signal, which is what you need to put VGA on a monitor. So what I tried this time is I found this chip called a LMH 1981, and what this does is it can take a C-Sync signal. It can take a C-Sync signal, right? So it goes in, and then it's able to make a H-Sync and a V-Sync signal from that. And I don't know exactly how it works, but on an oscilloscope it seems correct. The issue with doing it this way is that the VGA signal that this outputs, the v9958 GPU, it runs at a frequency that virtually no monitor in existence can actually accept. So unless you actually had an analog CRT monitor, it wouldn't work. I was not able to find a monitor that this worked with. It could also just be that it's not working and I did it wrong, but this just kind of isn't a priority right now. The S video signal that the Sony chip outputs is good enough. So it also has a tri-state buffer. Yeah, 74 LS 125. That's actually an optional thing where if I were using this card on an x86 computer, then instead of hooking it up to the Z80 CPU's weight line, this kind of wouldn't work that way. So what I did is I made a tri-statable weight that can be inverted or uninverted, and I could use that to control like motherboard logic to insert weight states on an x86 CPU if I really wanted. One thing I really have to point out is there is a mistake with this schematic. Okay, so you see right here, you see like all the power inputs for these logic chips. If you'll notice, if I click on this net, it's not connected to anything, right? So if I pull that up and I click on it, come on. Yeah, see all these chips, they aren't actually connected to anything because I made a mistake. So if you build one of these yourself, just remember that, fix that. Here's what I had to do to fix it. You just solder some wires together, connect all the voltages. No biggie. Right here's the screen. It's being recorded over S video, so it does look really good. Let's run something. It's like a hello world. That's a good one. Let's do that. Hello world. Yeah, there you go. Okay, now let's run a game. Yeah, there you go. Look at how good that looks. It's normally like really bad. Alright, let's look at a different game, see how that goes. Here's the snake game. It looks just as good and clear as the other game. Fun fact, that score counter can actually go all the way up to 65,535. It keeps track of score using a 16-bit value. I've never played this game long enough to actually score that many points though. This is a program that was made in C and not assembly. It's supposed to draw random rectangles to the screen over and over, but it doesn't really work right. It just has to do with something about the stack and registers. It's complicated. I'm not going to get into that right now, but this program does make a good video test.